Hello, ladies and gentlemen. Today we're going to talk about simplifying radicals and rationalizing the denominator. You have a foldable in your notebooks. Make sure that you're writing down good notes, and it's a really important topic, so we want to make sure that we're really understanding as we go and writing down questions we might have, so that way when we get to class, Ms. Kessler can answer those. So again, you're going to need a notebook. You're definitely going to want a calculator and something to write with. All right, so what is a square root? A square root you've heard of before, hopefully, and again, these are just the definitions. They're really good definitions to have in your notes. The square root of a number x is the number whose square is x. So again, if I square x, if the flip side of that is the square root of a number. So the notation, we read it as the square root of x. Okay, this notation, this is just our radical symbol. The number underneath is called the radicand. And again, this is just some really good vocab to know in case Ms. Kessler talks about it and refers back to it. So making sure you understand what those mean. On the right-hand side then here, should be on the front of your foldable. We call these the magical numbers. And the reason we call them the magical numbers is if we take a look at the square root of 16, some of us might jump and say, okay, well that has to equal 4. Yes, it does, because 16, again, it's magical because it makes that radical sign go poof, and we're left with just 4. 9, again, is magical because it makes it go poof, and we're left with 3. So it's a very similar pattern. The square root of 4 is 2, square root of 1 is 1, square root of 25 is 5, and we could just keep going down here. Square root of 64 is 8, 81 is 9, 100 is 10, 121 is 11, 144 is 12, 169 is 13, 196 is 14, and 225 is 15. So you could just go all the way down there and list those out. But again, these are the numbers I'm going to want you to have memorized all the way up through 15. These are the ones we use the most. Now, if you don't have them memorized, there's a trick you can do to help you come up with them on a learning check. If you take 1 times 1, you'd get 1. If you take 2 times 2, you'd get 4. If you take 3 times 3, you'd get 9. 4 times 4, 16. So you can just go and go, okay, 1 times 1 is 1, 2 times 2 is 2, or 2 times 2 is 4, excuse me, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, and you could just keep going on and on and on and on and use your calculator to help you get, okay, 15 times 15 is 225. So you can come up with that list instead of memorizing them. But again, these are the 15 magical numbers that I want to make sure that you have because they're going to help us as we move forward. So today we're going to use the product property, and the product property tells me that if I multiply the square root of a times the square root of b, it's the same as saying the square root of ab, so a times b under there. So what we're going to do today is we're actually going to do this in reverse. I'm going to give you something as a product under the square root, and we're going to split it up into 2 separate square roots. So we use this property to simplify and multiply radicals. All right, so the first thing then that we're going to want to do today is we're going to want to come up with the list of our magical numbers or our perfect squares. So again, if I go 1 times 1, that's 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 would be 49, 64 is 8, 81, 100, and I'm just going to stop there on this slide because if you notice the 3 examples that I'm doing on this slide are all less than 100. So I'm just going to stop there for now. So now again, what I'm going to want to do is again think of 28. 28 is a product. That means 2 numbers multiplied together to give me 28. What I want to think about is I want to think about, okay, well, which one of my perfect squares up here, my magical numbers, would go into 28? You could start with the highest number and work down. 36 obviously is too big, so I look at 25. Well, no, that doesn't go into 28. 16 doesn't go into 28. 9 doesn't go into 28, but 4 does. So what I'm going to want to do is I want to break this down into separate radicals. Okay, the first radical is going to be my magical number, so that's 4. Okay, well, what times 4 gives me 28? Hopefully you're thinking 7. And the reason I do this again is because remember, these magical numbers make my radical go poof. So this first one, the square root of 4, we know poof, it's going to turn into just a 2. And then I look at 7. Can I break 7 down anymore? Is there any other magical number that goes into 7? There's not. So then what I do is I just bring down that square root of 7. And this right here would be the simplified radical for the square root of 28. So as you work ahead then, again, we want to make sure that we have radicals and we want to simplify them down to the lowest they can. So we look at our magical numbers to see what goes into it. Okay, so then we look over here at 68. And again, you could start all the way up here at 64, but we know that that's not going to go in. And I would try the biggest, but you can always start from the bottom. So if I try, we can break 68 up into the square root of 4. And if I type into my calculator what 68 divided by 4 is, we would get back the value of 17. So again, 4 we chose from my magical number list. 4 makes the radical go poof. We're left with just a 2. Now I look at 17 and see if I can break 17 down anymore. There isn't another magical number that goes into 17, so I just bring down that square root of 17, and this would be my fully simplified radical for the square root of 68. Okay, next again, let's go over to 60 and we try all of our numbers. When you try all of your numbers, you'd realize, okay, well that's going to break down again into a 4, and then the square root of 15. So the square root of 4 is going to go poof because it's magical, gets rid of that radical. We get just a 2, and then we get the square root of 15 because that's not going to break down. Okay, so make sure that you jot down any questions you have from this slide as we kind of went through those last couple examples pretty quickly. So the next example we have then again, I'm not going to write the list out because you already have that in the front of your foldable, but we would look again, what is a perfect square or a magical number that goes into 75? My head tells me to work with 25. So again, we want to break this down into two separate radicals, the square root of 25. And then I think, okay, well, 75 divided by 25 would give me 3. So the reason I chose 25 again is because it's a magical number that makes my radical go poof, and I'm left with just a 5. And then you think about 3, if 3 can be broken down any further, and it can't, so we leave it as the square root of 3. And that would be my final answer. So as for 5, I'm going to have you guys do this one on your own, and I will check that one in class. But try number 5 on your own because I'm going to jump to number 6 because 6 looks just a little bit different than anything we've done in the past. So I'm going to leave that 3 alone for right now, and I'm going to kind of ignore it. So I'm just going to scribble it out for right now. I kind of ignore that, and I'm going to focus on just the square root of 18 and see how I can break this down into two separate radicals. Again, we want to look at our perfect numbers, our perfect squares, our magical numbers. The biggest number that goes into 18 that's magical would be a 9, and 9 times 2 would give me an 18. The reason I chose 9 again is because it goes poof and turns into a 3, and the 2 doesn't break down any further, so it stays the square root of 2. Now I want to bring back this 3 down here because I can't just forget about it completely. I just ignored it in the beginning, but now I have a 3 out front. Because it's out front and there's no operation here that is drawn out for me, we want to assume multiplication. So what you're going to do with that 3 out front is you're going to multiply it by whatever's on the outside of my radical here. I can't multiply inside the radical because there's that wall. We use this radical symbol as a wall, but it is going to give me 9 square roots of 2. Again, we can't multiply inside the radical because of the wall. We can only multiply on the outside to get the 9 square roots of 2. So again, maybe a little bit confusing, but make sure you jot down any questions you have. All right, so then just a couple more examples. Again, this negative 4 on the outside, I'm going to ignore it for right now, and I'm going to look at 56. Okay, when I think about 56, again, I want to think about which one of my magical numbers goes into 56. Does 4 go into 56? It does. So I break this up and I go, okay, I got the square root of 4. Well, 56 divided by 4 gave me 14. So 4 again is magical, makes the radical go poof. I'm left with a 2. I think about square root of 14, and if that breaks down any further, and it doesn't, so I leave it as the square root of 14. So again, I come back up here, well, I got to bring down this negative 4. Because there's no plus or subtraction sign here, we assume multiplication. And I can only multiply what's on the outside, so I get a negative 8 square root of 14. So this would be my final answer for that. So 8 and 9, because we've done plenty of examples from the video, I'm going to have you do 8 and 9 on your own for class tomorrow. So make sure that you do that, and I will check them when we get to class. All right, so rationalizing the denominator. Radicals cannot be left in the denominator. So again, if we think about a fraction, we have numerator and denominator. So North Dakota, right? So the denominator is in the bottom, We cannot have radicals in the bottom. So we need to make sure that we eliminate the radical, and by doing so, we multiply the numerator and the denominator by the radical that's in the denominator, and then we simplify. So again, making sure you have these really good notes to refer back to when you have questions moving forward. But let's look at some examples of what this looks like. All right, so our first example then. Our first example here is 15 over the square root of 5. And again, we can't have the radical in the denominator. So what I do is I multiply it by what's in the denominator to both top and bottom. Because what I do to the bottom, I have to do to the top. I want to keep this as 1. If you notice the square root of 5 over the square root of 5, that's just 1 when I simplify that. But I do this to get rid of that radical in the bottom, okay? So when I multiply on top, again, we can only multiply what's on the outside together or what's on the insides together. So the top is going to stay 15 square roots of 5 because I can't multiply them together because of the wall here, this radical wall. Over on the bottom, I get 5 times 5 because they're both under the radical, I can multiply them together. So I would get the square root of 25. Okay, so when I jump forward again, okay, 15 square roots of 5, there's nothing for me to multiply. But notice what type of number showed up in the bottom. That's one of those magical numbers. So the square root of 25, 25 makes the radical go poof, and I'm left with just a 5. So now you might be thinking, okay, well, I can probably still simplify this further. Remember, you can only simplify what's on the outside or what's all on under the radical. So again here, the only numbers I'm going to simplify here, I'll do this in red, is I can simplify the 15 and the 5 on the bottom because they are both outside of the radical. I can't simplify what's under the radical because it's under the radical. So 15 and 5, 5 goes into both, goes into 15 3 times, 5 once. Don't have to write that on the bottom, so I can just write this as 3 square roots of 5. And again, it could not simplify the 5 under the radical because it's just that, it's under the radical. Okay, so let's jump forward and let's do number 2. So number 2, again, we have to get rid of this 84 in the bottom. But before I get rid of 84, let's simplify it. And if I look at 84, well, what goes into 84? Does 4 go into 84? It does. So I'm going to simplify this first, and I'm going to get the square root of 4 and the square root of 21. 4 is going to make the radical go poof. I'm left with 2. 21 doesn't break down any further, so I leave that square root of 21 as is. Again, that 3 on the outside, I got to multiply it by the 2. So it looks like I'm going to get 1 over 6 square roots of 21. And by doing this, then, now I don't have to worry about simplifying later. I simplified in the beginning, so I don't have to do it in the end. So just like in example 1, I got to multiply by the radical that's in the bottom. Multiply by the radical that's in the bottom, both top and bottom. So again, on top, I'm going to get the square root of 21. On bottom, I'm going to get 6 square root. Okay, well, in my head, I got to do, okay, 21 times 21 on my calculator would give me 441. This isn't one of our perfect squares that's on our foldable, but it is a perfect square because I know I took 21 times itself to get it. So this is going to make the radical go poof, and I'm just going to be left with 6 times 21 because the square root of 441 is 21. So over here, the final fraction that I'm going to get is the square root of 21 over 6 times 21, which if you, again, plug that into your calculator, 6 times 21, that's going to give me 126. So this would be my final answer because I can't simplify any further because 21 is under the radical and 126 is not. Okay, the last example on this slide then is the square root of 2 over 75. So whenever you see this, I encourage you to give them each their own radical. So square root of 2 over the square root of 75. Again, from there, I'm going to change colors so it doesn't get too crazy. I want to break down 75. What's a perfect square that goes into 75? Hopefully you're thinking 25 times 3. That's going to go poof, turn into a 5 square roots of 3. So I'm going to have the square root of 2 over 5 square roots of 3. And again, a red flag going off in your brain should be that square root of 3 in the bottom. So I got to multiply by the square root of 3 to both bottom and the top. So on top, because they're both under the radical, I can multiply those numbers together to get square root of 6. On bottom, I'm going to get 5 square roots of 9, which again, 9 is a magical number. So I'm going to get square root of 6 over 5 times 3, which is going to turn into square root of 6 over 15. I can multiply the 5 and the 3 together because they're both outside of my denominator. There's no more simplifying because I have a number under and a number not under, so square root of 6 over 15 would be my final answer for this one. Again, if you have questions, make sure that you're starring them so we can address them when we get to class. All right, as far as 4 and 5 go, hopefully you can kind of struggle through these. Just get started on these because then when you get to class, we'll answer any questions you have. But I want you to do these last ones again on your own. So that way you can see, okay, no, I get stuck here, Miss Kessler. Can you help me figure out the answer to this one? So again, on your own, I want to thank you for taking good notes. When you get to class, I'm going to have you tell me the word elephant. And the reason I want you to tell me the word elephant is because that's going to be your bell ringer. I don't want you to tell anybody else, but once you get to class, you're going to grab one of those entry tickets and you're going to write elephant on the piece of paper and you're going to throw it in my bucket. Okay, so again, thank you for taking good notes and listening all the way through. Your entry ticket, your bell ringer is going to be elephant.